Hey calculus students! Today's lesson is how to solve separable differential equations. So the last couple weeks we've been looking at solving differential equations from a graphical perspective, meaning using the slope field. But now we're going to focus on the analytical perspective using equations. And so some of you might be thinking, wait, we already know what a differential equation is. We've already been solving a differential equation. And you're right. So for example, a differential equation you might have seen. Remember that a differential equation is just any equation that's a derivative that you can solve for the original equation. And so we've solved stuff that looks like this, like x squared minus 3. And just to solve this differential equation, you take the integral of both sides, the antiderivative, to get y equals 1/3 x cubed minus 3x plus c. And so here would be the general solution to your differential equation. And then if you had a particular point, let's make this easy for ourselves, 0, 3, then we could solve for c by plugging in the coordinate point and figuring out c equals 3. So then we know the particular solution would be this. I'm just writing this as an example to kind of remind you, yes, we do indeed know. My mom is calling me. I gotta ignore her. Hey, Mom?
Hi!
Hey, hi, Dad. So yeah, we already know how to solve differential equations, but here's this word, this is an extra word, a separable differential equation. And so this is the type of differential equation that we'll use when we have equations where it's not always possible to solve in terms of just x. So let's look at this first example and it should hopefully become clear. If you notice in this example, it's very different from the types of differential equations that we're used to. So up top is the equation that we're used to just in terms of x, but the differential equation we have down here is in terms of both x and y. And so these are the types of differential equations that we're going to be practicing to solve in this video because it involves something called the separation of the variables, okay? And so that's why they emphasize this. It's really important when solving separable differential equations to show the separation of the variables. So when we have an equation that has both x and y, we have to separate them out. So let's just jump into this example. So I will write the steps as we go. Kind of on the side. So the first step is to separate the variables, just like it says over there. Separate variables. And so what that means is to get everything with x on one side and everything with y on one side. So I see that I have like those in terms of y, and then I have dx and x squared, that's in terms of x. So I need to separate them and get them each on the same side. So in this case, I can kind of like cross multiply. So this would be y squared dy equals x squared dx. And that's it. That's separating the variables. I've done the first and most important step. The second step is to now integrate both sides. Just like we would in a normal differential equation, that's what we're going to do here. So I'll show that I'm taking the integral, the antiderivative. So on this left side, I'm just taking the antiderivative in terms of y, like I normally would. So this will become 1/3 y cubed. And then this one on the right-hand side is 1/3 x cubed. And some of you might be thinking, oh, you're forgetting something, Ms. Patterson. And I'm going to kind of turn that into my third step because we're going to be very particular. We need that plus c, right? So we're going to add plus c on the x side. So just the side with x is going to get that plus c. And the reason why is because I could technically add c to both sides. You don't have to write this part down. So let's say I added c to both sides. Well, c is just a constant, so I could combine these together, combine like terms. And on the right-hand side, well, I would get this. 1/3 y cubed equals 1/3 x cubed plus c2 minus c1. Well, if you think about it, if I just have a constant minus a constant, this is just a constant. It could be called c3. And so the reason why we just add it on the x side is just to make it more simple. So we don't have to have two constants. That would be silly because when we add them together, it just makes another constant. So we just make it more simple by only adding the constant on the side with x. Okay, so you don't have to add the plus c on both sides. And then I need one more color, purple, for our fourth step. Oops. And that is just to solve for y. So now we want y by itself to fully solve the differential equation. So I'm going to multiply times 3 to cancel those 3's out. I get y cubed equals x cubed plus c2. And then I will take the cube root to cancel out the cube power. So this becomes y equals the cube root of x cubed plus c2. Or, I actually don't need this 2. This is just a constant, plus c. There we go. So here are the steps that you will follow for solving a differential equation and an example of it on the right-hand side. In this problem, it also asks us to find these particular solutions, since we know that this is just my general solution. So here's my general solution. It has the plus c. And then we can find these particular solutions. So let's go ahead and just do these two. We can skip this last one. Yeah. So if I solve for y of 0 equals 2, this just means that I have the coordinate point 0, 2. So I'm going to use my general solution and the point 0, 2 to find the particular solution at that point. So let's plug in 2 for y, and then 0 for x. 2 equals the cube root of c, and then to solve a cube root, I will cube both sides. So I get 8 equals c. So my particular solution is y equals the cube root of x cubed plus 8. That seems, oh yeah, that's much bigger than usual. Yeah. And then for 2, I'm using the, maybe I like it bigger. We'll do that one. We'll use the other point, which is 0, negative 2. So I'm looking at 0, negative 2. Plug in negative 2. And let's cube both sides. When I cube a negative, you have to be careful to cube everything. So I'm going to put parentheses around the negative and the 2 to make sure I'm also cubing the negative sign, because negative 2 cubed is actually negative 8. So my answer is a little bit different. Minus 8, like that. Cool. And so we can kind of see the answers to the differential, the solutions to the differential equation. Here is the first one. So going through 0, 2 kind of makes this really weird graph. And then going through 0, negative 2 makes this other solution. So that's it. That's the steps for solving a separable differential equation.